Alright, hi Java students, this is a review video. So go ahead and get out a piece of scratch paper so that you can write along with me. You'll probably need a few. We're going to talk about a lot of different things. So the first thing that we're going to talk about is the idea of probability. Probability is the likelihood of an event. Now we say event to mean just about anything. And when we're talking about probability, we use an equation of what we want divided by the total number of outcomes. So for example, if you're thinking about like a dice, dice have sides 1 through 6. So they have options of 1, 2, 3, 4, 5, 6. You can figure out the probability of landing on a number that's even, a number that's bigger than something, based on figuring out how many is what you want. So we would write notation, we say P and then inside parentheses, so probability of rolling an even number, let's say. Even numbers would be things like 2, 4, and 6. So there are 3 options that we would want out of a total 6 options, because there are 6 sides on that dice. 1, 2, 3, 4, 5, 6. So my probability is 3 out of 6. And that's a fraction. I can reduce that fraction. I can figure it out as a decimal, as a percent, but there we go. That's probability. So then from here, our probability is leveled up, and we started thinking about having 2 events. So let's say flipping a coin and rolling a dice. So probability of flipping heads on the coin and then rolling a 6 on the dice. So the 2 events would be flipping a coin and roll a dice. Or a die, I should say. So flipping heads on a coin, there are 2 sides to a coin, and one of them is heads. There are 6 sides on the dice, and only one of those sides is the number 6. So let's think about it. All of the different possibilities that we could have had. So for this example, I could have flipped heads and rolled a 1, flipped heads and rolled a 2, flipped heads and rolled a 3, flipped heads and rolled a 4, flipped heads, rolled a 5, flipped heads, rolled a 6. I could have flipped tails and rolled a 1, tails and 2, tails and 3, tails and 4, tails and 5, or tails and 6. So in total, there are 12 options of what could have happened when I did these 2 events together. So that means I just take out of those 12 options the one that I want. I want flipping heads and then rolling a 6, which is that option right there. There is exactly 1 of those options. So that probability is 1 out of 12. Okay, so then what I'm trying to figure out is how do these 2 numbers relate to that one? How does 1/2 and 1/6 turn into 1/12? Well, it turns out 1/2 times 1/6 is equal to 1/12 because we multiply across our numerator and across our denominator. So that means that when we have multiple events, we multiply those values. So multiple events that we want both of them. We're going to take the probability of event 1 and we're going to multiply it by the probability of event 2. So this is for sure something that we want to have written on our paper, as well as this thing at the top about probability, if you are feeling like that's new information today. For sure, for sure. This is our example. My hope is that you write out this example, but for sure have this part, for sure have this part. All right, so given that, how about you try these problems? Pause the video, try these problems right now. Do it, hit pause. All right, here is the answers for those now that you're back. Check your answers, check your work, both the notation and the answer. How'd we do? All right, let's try our next topic. Our next topic is going to be a similar type of situation. So this one says you have a bag of M&Ms, 57 are in the bag. 7 of them are red, 7 are brown, 8 are yellow, 14 are blue, 11 are orange, and 10 are green. Our favorite color of M&M is brown, and so we're trying to figure out the probability of pulling a brown M&M, eating it, and then getting to pull another brown M&M. So this will feel similar to the last problem that we just did. So pull a brown M&M and eat it, and then pull a second brown M&M. So for that first M&M, there are 57 total M&Ms in the bag, and 7 of them are brown. However, after you pull that first M&M, you eat it, you consume it. It is no longer in the bag, which means when you go to do your second M&M, this second event here, there are no longer 57 M&Ms in the bag. There's only 56 because you ate one. And there are no longer 7 brown M&Ms in the bag. There's only 6 because, again, you ate one. So then, like we've seen from that previous set of notes, if we want the and then, meaning the two events together, we are going to multiply the probabilities. So 7 over 57 times 6 over 56. So multiply across the numerator, and then we're going to figure out what 57 times 56 is, and that turns out to be 3,192. So that's our probability. So now we have to think about whether or not we replace things or whether or not we don't. So replace or not changes our probability. So we have to be careful here. This is a takeaway again that I want you to make sure that you have written on your paper if you weren't following along with that full example. All right, again, we're at a point of pause the video. You try out these problems. Pause now. All right, here's your next set of answers, so check your work there. Hit pause if you need to see those answers for longer, see how you did. And let's move on to our next topic. We are going to talk about 3 different diagrams, and we're going to talk about one special case, and then we're done. I know this feels like a lot. So we are going to talk about diagrams, which is different ways to organize our situations so that way we don't always have to have this novel like we've seen in that situation 3. We can organize our situation a little bit differently. The first that we're going to talk about is an area model. The way an area model works is this is a rectangle. This big rectangle is the full shape. However, each individual rectangle inside also has dimensions on it. So for example, this rectangle is 1/2 by 1/4 according to this information, which means its area that's filled in the middle is base times height, like we know rectangle area to be, so it's 1/8. So we multiplied the 2 numbers that were on the outside in order to get the number on the inside. So here it would be 1/2 times 3/4 to get those 3/8. So that's the way the area model works. Now, the numbers that we're seeing there came from, well, what was here in this problem. It says that we had a spinner that had blue and yellow. Blue took up 25%. So blue taking up 25% means blue is 1/4. That means yellow has to be the rest, so yellow is the 3/4. Then the second spinner is half fuchsia, which is like bright pink, and half orange. So then that is fuchsia gets 1/2 and orange also gets 1/2. So that's how we found the 4 outside numbers, and then to get these inside numbers again is multiplication. Now the reason that this is cool is because now I can ask you probability questions, for example, like what's the probability of spinning fuchsia? Oh, I can't spell that word. And the probability of spinning fuchsia is, well, exactly as we thought. It was 50-50 or 1/2. But I can also say things like, what's the probability of spinning blue and fuchsia? I want to spin blue on the first spinner, and then I want to spin fuchsia on the second spinner. And where that happens in my area model is at that intersection right there, which is 1/8. We can also say things like not, which would mean to look at the other category. I'm not going to write that one out, but for example, if we say not orange, that would mean ignore orange and only look at fuchsia, or vice versa. And then the final one that we are going to do is an or probability. So this would be the probability that we spin blue or we spin fuchsia. I want to make sure that I'm not ruining something for myself. Yep, okay. Spin blue or fuchsia. So now spinning blue and fuchsia would work. That would be a case we'd want to consider. Spinning blue and orange would be a case we want to consider because it still contains blue, as well as fuchsia and yellow, because then it would still contain fuchsia. So we want to consider all three of those probabilities. Now, they're not all going to happen. Only one of them is going to happen, so we add up those probabilities. So when we see the word or, we're going to add the options. So in this case, that turns out to be 5/8. So that's on an area model. There's another diagram that we're going to use to represent the exact same scenario, and this is called a tree diagram. We start by showing one event in all of the ways it can split off, and then for that first event, all of the options that split off from there. So first option for the spinner, we have blue or yellow. If we've spun blue, we have options of fuchsia and orange. However, if we've spun yellow, we still have options of fuchsia and orange. So that's how we can read the tree diagram. As well, the probabilities that are on the outside, you'll notice, are the same as the ones that are on the outside of the area model, to represent the likelihood of each individual event. At the bottom of the tree diagram, we multiply our way down to get to these bottom values. So this bottom value down here came from reading down this branch 1/4 times 1/2, just like we multiplied inside of that area model table. All right, so we can use this tree diagram to calculate the same probability. So we can say probability of fuchsia. And when I look here, the probability of fuchsia, I can either notice that it's 1/2 overall, or I can see that it's 1/8 plus 3/8, or 4/8 altogether. If I'm reading at the singular source, those are the same values. If I want to get to the bottom values, that's where I would add. I can also figure out the probability of blue and fuchsia. I don't know why I picked the hardest word to spell. So blue first, then, whoops, don't turn into a line. Blue first, then down to fuchsia means I care about that branch and only that branch, which is this 1/8 right here. And then finally thinking about probability of blue or fuchsia. On the tree diagram, I can read blue and orange would work for or, blue and fuchsia would work, and so would yellow and then fuchsia, all three of those situations again. So we're going to add up the 1/8, 1/8, 3/8. Now, if you notice, all of these answers should be the same in both diagrams. That's on purpose. So now I want you to copy and pause here, copy these diagrams down. I'm going to go ahead and erase some of my annotation that's here so that way you can see the diagram more clearly. Copy the diagram that's down, hit pause. Then when you're done, try out those 4 problems. So hit pause again, try those 4. All right, check your answers here. Let's see how we did. I'm only showing you on the tree diagram, but my hope is that you got it using either or both of those diagrams. Okay, our second to last thing is a two-way table. This is our third and final diagram. This diagram uses whole numbers. We use whole numbers for this diagram. And we'll have a situation and we'll have to place the numbers. So this says a store sells handbags in 2 colors, black and white. They also come in 2 sizes, large and small. Right now they have 24 black handbags. So black total, they have 24 handbags. Specifically, we know, oops, I already used that color. Specifically, we know that 8 black handbags are small. So that will go right there. And 13 white handbags are small, so that will go right here. Finally, it tells us that there are 50 handbags in the store, which is the total of both the colors and the sizes. Then our two-way table is going to add up along the rows and columns. So we can figure out those missing values. 8 small handbags that are black, 13 small handbags that are white, means in total we had 21 small handbags. If we had 50 total handbags and 21 of them are small, that means the other 29 needed to be large. If we had 24 black handbags out of 50 total, that means 26 needed to be white. Of the white handbags, if 13 are small, 13 must be large in order to get 26 total. And finally, of the black handbags, 8 are small, so the remaining 16 must be large in order to add up to 24. So 8 plus 16 equals 24, 13 plus 13 equals 26, 21 plus 29 equals 50. But also, 8 plus 13 equals 21, 16 plus 13 equals 29, and 24 plus 26 equals 50. So we can then calculate probabilities just like we did in the other situations, thinking about those and, ors, and nots. So pause your video right here. Try out these 4. All right, then let's check our work for those 4. And we will talk about our last topic, our final topic. Yep. Nope, I'm on the wrong thing. Here we go. Final topic, and that is a conditional probability. That is the likelihood an event is going to happen based on a previous event. So let's go ahead, pause the video, write that down if you need to. Here's our example. We're going to figure out the probability that if we selected a person at random, we want to know the likelihood that we select a sophomore. And then the key word for conditional probabilities is this word given right here. And that says given that they are a geometry student. And what that means is we already know the student is a geometry student. Maybe we didn't look at all the students. We only are choosing to look at the geometry students right now. So in my brain, this given information here tells me where to look on the two-way table. I only care about students that are taking geometry. So in this moment, I don't care about the rest of the numbers. Those go away. I only care about geometry students. And now I want to know the probability that they are a sophomore. So there are 200, oops, what did I do here? There are 200 sophomores. But the total now is no longer out of 1,000. It's only out of the geometry students because we know that the student is taking geometry. So it's 200 out of 350. So try to scribble out the table like this if you need to. Make a new table every time if that helps you out. You're going to fill in this two-way table and calculate those 4 probabilities. Pause the video, try those out. And here you go, final answers. I hope this was helpful. We have a few more topics that we haven't yet covered. Expected value is one of them, which luckily was a day of class that you were there for. So actually, I'm lying. That was the last topic. So that's all of the things that are in the probability unit. Please now take a look at the email if you still have time in class to see any other review exercises or things that you might be able to work on in order to keep doing more practice.